In this lesson, we're going to study graphing inequalities in two variables. First, we're going to look at linear inequalities. And when we look at linear inequalities, we're going to look at two ways to graph them using slope-intercept or the two-intercept approach. And then we're also going to graph inequalities that involve parent functions like parabolas, circles, and absolute value graphs. Now let's first refresh our memory on some things we already remember about graphing inequalities. First of all, if we don't have an equal sign underneath the greater than or less than, the boundary is dashed. But if we do have an equal sign, the boundary is solid. Next up, if we have the equation solved for y and it says y is greater than, we can just shade above. And if it's solved for y and it says y is less than, we can shade below. And lastly, if it's not solved for y, we're going to test the point 0, 0. It's easy math, and then we can see is 0, 0 in the shaded region, and that'll help tell us where to shade. All right, let's start with these first two. Clearly, we have linear equations. They both look like the form y equals mx plus b. So let's start with this one. Our y-intercept's at -3. Our slope is 1/2, so we go up 1 and over 2. And I'll go grab my line tool. And when I grab my line tool, I'll draw this line like so. And you should be noticing, wait a second, Mrs. Young, it's not equal to. We don't want a solid line, so we go up here, and then we switch it to a dashed line. All right, so far so good. It's greater than, so we're going to just shade above. And remember, we're always thinking in terms of above and below for shading. All right, let's look at this next one. Also in the form y equals mx plus b for our boundary. There is no b, which means we're adding 0, so b is 0. My slope is 3, so I go up 3 and over 1, and I'm ready to draw that boundary line. So here's my boundary line, and it is equal to, so I can just leave it as a solid line. Last thing, it's less than, so I'm going to shade below the line. And we're going to think about this as being below, not to the left or right, but below. These next two questions are also linear equations, but they're not solved for y. We could solve for y, but there's really an easier way to graph them. We're going to find the x and y intercept. Now let's start with the x-intercept. When we have an x-intercept, y equals 0. And when y equals 0, it's kind of like it disappears. We can just look at this equation and see, oh yeah, my x-intercept is going to be 3, because if 2x equals 6, then x has to be 3. I'm going to move my 0 over to the x and find the y-intercept. If 3y equals 6, then my y-intercept is 2. And now I've got 2 points, and that's all I need to graph my boundary. So I'm going to graph this boundary like so. It's equal to, so it's a solid line. Now this is not solved for y, so I'm going to use the testing 0, 0. So here's the point 0, 0, and I plug it in. 0 plus 0 greater than or equal to 6. Is that true? No, it's false. That means 0, 0 is not in the shaded region, and so I'm going to shade up here where 0, 0 is not. All right, let's try the next one. Same idea. For the x-intercept, we cover up y, and we get x equal to -5. So I've got a -5 here. For my y-intercept, I cover up x. Now be careful, don't cover up that negative, just x. And now I'm going to take -5 divided by -2, and my y-intercept comes out to be 2.5. Now I'm going to draw that boundary line. There it is, but we notice it's not equal to, so I want to change that to a dashed line. And just like before, because it's not solved for y, I am going to test that point 0, 0. Let's move my 0 here so I can see it. And when I test that point, I plug it in and I say, okay, 0 minus 0 less than -5. Is 0 less than -5? No, it's a false statement. So again, I'm not going to shade where 0, 0 is, but I'm going to shade up here above. Now I want you to notice that I'm shading above even though that it's a less than, because it's not solved for y. I had to test the point. 0 is not less than -5. It's not in the shaded region. Great. Let's try some with parent functions. Here is an absolute value graph. So remember that absolute value graph, that's our V. And we've got transformations here. Let's see, it looks like it goes right 2 and write that over there. Right 2 and up, no, not up, but down 1. Down 1, so let's go right 2 and down 1, and we have a V like so. All right, so there's our absolute value graph. And when we look at this, let's see, it's a solid boundary because it's equal, and it says y is less than. Well, if y is less than, we're going to shade below. So here we go. We shade everything below that V, and we've got it. Let's try this next one over here. This time we have a parabola. Let's see, we've got a few things happening here. The negative, it flips over the x-axis. This plus 3, of course, shifts it up 3. And there's also a vertical stretch. So a vertical stretch of 2. So we'll get all those things in there. So let's see. We're going to be shifted up 3. We're opening down, and that vertical stretch of 2 means instead of going over 1, down 1, we're going to go over 1, down 2. So there we go. We've got a pretty skinny looking parabola. Dashed line because it's not equal to. So let's try and get this curvy up there. All right. There we go. And now it's less than. So if it's less than, I'm shading everything underneath the parabola, like so. All right, we have 2 more. And these are graphs of circles. So we've got to remember our circle properties from last semester. This first one, remember when we have x squared plus y squared, it's equal to r squared. Our center is going to be at 0, 0. And our radius is the square root of 4, which is just 2. So let's go, starting from 0, 0, we're going to just go out 2 in all directions. So 2, 2, negative 2, negative 2, and we notice it's not equal to. So I'm going to draw this circle with a dashed line. All right, so this one is not solved for y. So I'm going to test that 0, 0. So I'm just going to say 0 plus 0 less than 4. Yeah, 0 is less than 4. This one is true. That means where I have 0, 0, that's where I'm going to shade. And in this case, it's actually shading on the inside because our region now isn't above and below, but it's inside the circle and outside the circle. And since 0, 0 is inside, that's where I'm shading. The other way to think about this is we're finding all of the circles where the radius is less than 2. So it's really, there's a whole lot of circles, and I'm just shading all circles whose radius is less than 2. All right, let's try one more. Here's another circle. This one has been shifted over. Our center is, let's see, right 2 and down 3. And our radius is the square root of 1, which is just 1. So we're going to go to 2, negative 3 for our center, and then we're going to go 1 unit in each direction. We get this small circle here, and it's a solid because it's equal. So there's my circle, and it's greater than 1. Now I think because it's greater than, it's going to be on the outside, but let's just show you how that 0, 0 can still work out. 0 minus 2 is negative 2 squared is 4. 0 plus 3, which is 3, and 3 squared is 9, greater than or equal to 1. Is 13 greater than or equal to 1? Yeah, that's a true statement, which means 0, 0 out here is in the shaded region, which means we're going to shade everything but that circle. So everything outside of the circle is shaded. All right, that should be enough for you to get going on the next homework assignment.